interpretation of simple harmonic motion with the help of circular motion. It seems as if circular motion is a different thing, is a two-dimensional motion, and simple harmonic motion is a one-dimensional motion. But we can relate simple harmonic motion with circular motion and understand it properly. And how we do that? Look here. We have a rod of length A. Now remember, what is capital A? Amplitude. We have this rod, its length is A, and it is rotating with angular velocity omega. What is omega? Angular velocity. We will relate this angular velocity to angular frequency of simple harmonic motion, and you will understand this part. But first, understand this circular motion. This is omega. Remember, this omega is angular velocity. And the most important thing is this omega is constant, which means this rod throughout is moving with constant angular velocity. Its path, the tip, if you look at the tip of the rod, it describes this circular path. That's a circular path. Now, imagine we have a screen which is present here. We have a screen over here, and light is coming from this side. These are light rays. Now, light rays are coming from this side. You have your rod over here, and this rod is executing circular motion with constant angular velocity. This is t equals to 0. At t equals to 0, this is the position of the rod. Now, if I ask you where this rod will be at time t, small t, you will say that at some time t, you found that rod is present over here. This is the position of the rod. Then, what is theta? What is theta? Angular displacement. So if I ask you what is angular displacement, you will say that theta, which is angular displacement, What is displacement? Velocity into time. When can you use velocity into time? When velocity is uniform. Similarly, when can you write angular displacement as angular velocity multiplied by time? When angular velocity is what? Constant, which it is in this case, and therefore we can write theta as omega t. So at time t, angular displacement of the rod is theta, which you know is omega t. Now if I ask you, light rays coming from this side, this is the rod, and therefore you can see that this much portion of light rays will be blocked by this rod. As these light rays arrive, they are blocked by the rod. This light ray, this is also blocked by the rod. A light ray coming from this part It will simply go through. That means this much portion is blocked by the rod. And if you block something, then you know that you will see shadow of the rod casted on the screen. So, what is the length of shadow? If I ask you at time t, you will connect these two lines like this, top of the rod and this end of the rod. If you connect them like this, then you know that this is the shadow of the rod. Shadow of the rod. Which means what? At time t, rod is like this, and on the screen you see its shadow. If length of shadow, if length of shadow is x, then you know that length of this portion is also what? X. They are of same length. Same length. Now, length of the rod is A. If this is A, then this is also A. Length of the rod. Now look at this right angle triangle. In this right angle triangle, this is your perpendicular and this is your hypotenuse. And therefore, if I ask you what is sine of theta, what is sine theta in this figure? You will say x divided by a. Sine theta becomes x divided by a, which gives us x as a sine theta. And what is theta? Theta is omega t. Omega t. Now, I hope you remember x equals to a sine omega t is that case when object starts from mean position and aims for the positive amplitude. Now comes this equation which is related to simple harmonic motion. We have developed this equation in this figure. Try to understand this part. This is the rod. White rays are coming from this side. They are blocked. Initially, at t equals to 0, rod is at this position. If this is the position of rod at t0, you will say that at t equals to 0, tip of shadow is at this point. Rod is like this, you don't see any shadow, or you say that shadow is exactly at this point. Now, as this rod completes the circle of angular position theta, of angular displacement theta, shadow, its tip reaches this point. And as this tip reaches this point, its length is giving us equation of simple harmonic motion when things start from the mean position. Now, let's look at this rod. Now, as this rod reaches and completes 1/4 circle, 1/4, when it reaches the highest position over here, you know that the length of shadow will be up to here. And what is this length? This is the rod of length A. And therefore, you see that from here to here, length is what? Capital A. Which means at this point, your x becomes what? Capital A. When this rod has completed 1/4 circle, shadow, its tip is over here and x equals to capital A. Now, as this rod moves for theta equals to pi 180 from this to pi by 2 to 180, as it comes down, you can notice that this tip of shadow will also come down. This is the rod. As it comes down, these rays, they will simply pass, but these are blocked. As it further comes down, this ray will also pass, which means now this tip is coming down. When rod completes half circle, tip of shadow will be again at this position. Now when this rod further completes the circle, 3/4 circle is complete, you can see that this tip will be now over here at this position. And finally, when rod completes a full circle, tip of shadow will arrive back at this position. So, if you notice path of the tip, then this path looks like this. Starts from this position, it goes up, it comes back down, it reaches the negative extreme, and then goes up like this. That's how tip of shadow is moving. Whereas throughout, rod is completing a circular path. Now, when this rod completes a full circle, in that time, tip of shadow has completed one oscillation, which is given by x equals to a sine omega t. That means what? If somebody is looking at the tip of shadow, then you know that in simple harmonic motion, speed is not constant. At the mean position, speed is what? Maximum. At amplitude, it becomes what? 0. But if I ask you that which one completes its motion first, this rod, it completes a full circle first, or tip of shadow completes full oscillation first, then you will say that they both take same time. Which means we will say that time to complete circular motion, is same as time to complete one oscillation of simple harmonic motion. Time which this rod takes to complete full circle and time which tip of shadow takes to complete one oscillation, they both are what? Same. Now, in simple harmonic motion, you know that x is this, and when you go for velocity in simple harmonic motion, you differentiate it and you get a omega cos of omega t. This v, you know, is not constant. It's a function of cos. At mean position, it is maximum. At amplitude, it becomes 0. And therefore, if I ask you that, can you use time as distance upon speed for simple harmonic motion? Then answer will be no. Why? Because time equals to distance upon speed. It is used when throughout the distance, speed remains what? Constant. And therefore, we cannot find time in simple harmonic motion using t equals to distance upon speed. We cannot. But if I ask you, can we find time taken by the rod to complete full circle, in this form? Angular displacement divided by angular velocity, then you will say yes. Why? Because distance upon speed, it is used when speed is constant. Displacement upon velocity is used when velocity is constant. Angular displacement divided by angular velocity is used when angular velocity is constant, which it is in this case. So when this rod, it completes a full circle, then what is the angle which it has completed? That angle is what? 2 pi. With what angular velocity? Omega. So this is the time to complete one circle. But you know that this time is also same as the time which oscillating particle takes to complete one full oscillation, which is given as what? T. That's the reason in simple harmonic motion we use T as 2 pi upon omega. I hope you understand the origin of T equals to 2 pi upon omega. This is coming from circular motion. We cannot directly calculate time because speed is not constant, and therefore we took advantage of what? This uniform circular motion, and this uniform circular motion is giving us T as 2 pi upon omega. Now, once we found that T is coming as 2 pi upon omega in simple harmonic motion, we needed a name for omega. A name for omega means what? What is omega basically? Angular velocity. But if somebody is only looking at the tip of the shadow, then this tip of the shadow is executing what? Linear motion. It's going up and down, up and down. That is one dimensional motion. You do not see any circular motion when tip of shadow is executing S.H.M, which means we must give this omega some new name, and that new name for omega in simple harmonic motion is angular frequency. Angular frequency. And therefore, if you remember the first class of S.H.M, I told you that this angular velocity is equivalent, this angular frequency in S.H.M is equivalent to what? Angular velocity. Just to give it a different name, because we do not see any circular motion, we don't want to say angular velocity, but it is equivalent to what? Angular velocity, and therefore this omega, which for circular motion is angular velocity, for S.H.M is angular frequency. Now, similarly, what is theta? Theta is what? Angular displacement. Now, this theta, which you see here as omega t, which you see here as omega t, this theta is angular displacement, but when you look at this tip of shadow again, you do not see any angle being formed because it's only what? Linear, one dimensional path, and therefore this theta in simple harmonic motion is called phase. Phase. What is theta? Theta is angular displacement for circular motion, but for S.H.M it has a new name, which is what? Phase. That means once you are looking for phase, keep this thing in your mind that phase is nothing but angular displacement. Now, what is the advantage of introducing theta or phase? You know that when an object performs simple harmonic motion, when you are at this position, this is called what? Mean position. At this position, this object is going up. This is amplitude, positive amplitude. When you arrive at this point, this is again mean position, but object is going for negative amplitude. This is negative amplitude. This is again what? Mean position, and object is going up for the positive amplitude. So if I ask you, describe this position, then you will say object is at mean position and is going for positive amplitude. You have to say this much, you have to present this much information. But if you say that phase in simple harmonic motion is 0, Once you say that phase is 0, it means rod is present here, its shadow is over here, and this rod is going up. This rod is going up, you know that tip of shadow is also going up. Once you say that phase is 0, this phase equals to 0, it means object is at mean position and is going for positive amplitude. Again, when this object completes half oscillation and arrives at this position, how do you define this position? Object is at mean position and is going for negative amplitude. But now you can simply say that phase of the object is what? Pi 180. Once you say that phase is 180, that means look at this tip. When this phase is 180, this tip you know is going down. If it is going down, automatically you know that the shadow is coming down. Once you say that phase is 90 or pi by 2, you know that once I say that phase is 90, that means this angle is what? 90. If rod is here, then shadow is over here. That means tip of shadow is at the amplitude. When you say that phase is 90, it means object is at the positive amplitude. And similarly, when you say that phase is 3 pi by 2, phase is what? 3 pi by 2, then your object is at negative amplitude. You also know that you can call it 270, that is 3 pi by 2, or you can simply say minus 90 or minus pi by 2. So when object is at this position, phase is what? 270 or 3 pi by 2 or minus 90 or minus pi by 2. And once this rod has completed one circle, that means tip of shadow has completed one oscillation, one complete oscillation. What is the phase? What is the phase over here? You will say that phase is 360 degrees or 2 pi. So once you say that phase of the object is 2 pi or 360, it means object has completed one oscillation. When you say that phase is 0, object is just starting its S.H.M. Once you say that phase is 360, object is again at the mean position, is going up for the positive amplitude, but you know that it has completed one full oscillation. This is the advantage of circular motion if you want to understand simple harmonic motion. Basic advantage lies in this part. This formula of time, which is equal to distance upon speed, cannot be used in simple harmonic motion. It is maximum over here, 0 at this point. Again maximum, 0 at this point. Object is executing simple harmonic motion with variable speed, and I cannot use this formula. But throughout, tip of the rod is executing a circular motion with uniform angular velocity, and therefore I can use this format of 2 pi upon omega. Write down few points and then note down each and every thing. Write down the points. When tip of rod makes an angle of 0 with the horizontal line, tip of shadow is at the mean position. Tip of shadow is at the mean position. When rod completes 1/4 circle, Tip of shadow, tip of shadow is at the amplitude. Tip of shadow is at the amplitude. When rod completes half circle, when rod completes half circle, tip of shadow, tip of shadow is at mean position but is going for negative amplitude. But is going for negative amplitude. And when rod completes full circle, and when rod completes full circle, tip of shadow also completes one full oscillation. Tip of shadow also completes one full oscillation. And therefore, and therefore, time taken to complete one full oscillation, time taken to complete one full oscillation during simple harmonic motion, during simple harmonic motion is same as that taken by the rod, taken by the rod to complete full circle, taken by the rod to complete full circle. Next line. But in simple harmonic motion, but in simple harmonic motion, as speed is not constant, as speed is not constant, we cannot use time equals to distance upon speed. We cannot use time equals to distance upon speed, but for the circular motion, as angular velocity is constant, for circular motion, as angular velocity is constant, we can use time equals to angular displacement, time equals to angular displacement divided by angular velocity. Angular velocity in circular motion, angular velocity in circular motion is called angular frequency in simple harmonic motion. It's called angular frequency in circular motion. They both are identical. They both are identical. Similarly, angular displacement in circular motion, angular displacement in circular motion is called phase in simple harmonic motion. It's called phase in simple harmonic motion. Phase provides us with all the necessary information regarding position and direction of motion during simple harmonic motion. During simple harmonic motion. Wrote down this much. Now, let's understand the general case of simple harmonic motion. In the previous setup, this was the position of the rod at t equals to 0. But if I say that rod starts from this position, this angle is phi. Rod is again doing the same thing. It is executing circular motion, but instead of finding the rod at this point, this orientation, you found that initially rod is like this. If this is the initial position, then you will say that at t equals to 0, angular displacement of the rod is phi. At t equals to 0, angular displacement of the rod is phi. Or we'll say that phase, initial phase is phi. So the phi which you saw in general equation of simple harmonic motion is nothing but initial phase. This phi is your initial phase. Just don't worry, you will understand it. So this is phi, t equals to 0. You know that length of the rod is a. Now, again the same thing, rod is rotating with uniform angular velocity omega. This is initial position at time t. At time t, we found that rod is over here. If this is the position of rod at time t, then you know that this much angle, this rod which it has covered is what? Omega t. If this angle is theta, what is angular displacement? Angular velocity multiplied by time, starting from this position. From this to this in time t. In time t. Angle covered is what? Omega t. But if you look at the shadow, you know that for shadow, now let's directly draw the figure. That's how this rod looks. What is the total angle from this horizontal position? Phi plus theta. This total angle is now theta plus phi. Length of the rod is what? A. Length of the rod is what? A. And the shadow which it casts on the screen, you know that this much portion will be blocked. This much portion will be blocked, and length of that portion is what? X. This is X, this is 8. You know that X can be written as A sine theta plus phi. What is theta? Theta is omega t plus phi. What is this? General equation of simple harmonic motion. A sine omega t plus phi. When we developed this equation with the help of A equals to minus omega square x, I hope you remember this phi was called what? Constant of integration. But now you know that this phi is what? Initial angular position of the rod or initial phase during simple harmonic motion. Now, the case which you saw in the previous part, in that the rod was like this at t equals to 0, which means you will say that initial phase in that case was 0. If rod starts from this position, then you will say that initial phase is 0, which is called case 1. When you say that rod starts from this position, if rod starts from this position, you know that tip of shadow is initially at the amplitude, which means you will say that this is case 2. In case 2, object starts from positive amplitude. Or you will say that if rod starts from this position, beginning at t equals to 0, at t equals to 0, if rod starts from this position, you will simply say that phi or initial phase is what? 90 degrees or pi by 2. If you remember those cases, then in case 1 we got the value of phi as 0, and in case 2 we got the value of phi as what? 90 degrees. So you can now understand that if I say that rod starts from this position, at the beginning rod is found over here, then you will simply say that initial phase is 3 pi by 2 or minus pi by 2. I hope you understand the general equation with the help of circular motion. This is phi, which is initial phase. What is phi? Angular displacement of the rod initially, which is same as initial phase. Now, what is the advantage of this circular motion part? If you remember, in case 1, for case 1, we had a question like this. The advantage which you get with the circular motion model. For case 1, I gave you a question like this. At t equals to 0, object is at mean position. And then in what time it completes half of the amplitude. At t equals to 0, x is 0. Object is at the mean position. At what time x is a by 2. This is the position where x is a. I'm interested in this portion. And how did we handle this part? We wrote x equals to a sine omega t. And then x was a by 2. And we solved for omega t and we found the time. That was the way we handled this question previously. Now, if we try to answer this question with the help of circular motion, then look at the advantage. This is the rod, and this rod, its tip is executing circular motion. We are discussing case 1. Remember, t is 0, x is 0. This figure, remember, is equivalent to this figure. So, this is the rod with its initial position, t equals to 0. Now, if I ask you, what should be this angle theta? What should be this angle theta? So that length of shadow is a by 2. If I ask you this question, that if rod starts from this position t equals to 0, then after what time t, length of shadow will be half of the length of rod itself. This is what A. This question and this, they both are same thing. Starts from mean position. After what time object is found at half of the amplitude. Rod starts from this position. This is the tip of the shadow. As rod moves and reaches this position, tip of the shadow is over here. Now, with this, if you remember, I had told you that time for first a by 2 and time for second a by 2. Total is a. For this and this, times are not same. Because in simple harmonic motion, when you are at mean position, you are moving with maximum speed. And as you go and reach amplitude, your speed continuously decreases. But now look at this. In this, you know that your omega throughout remains what? Constant. Which means if omega remains constant, then you know that this rod will reach over here after what time? T by 4. From this to complete one full circle, what is the time? Capital T. To complete one full circle, what is the time? T by 4. Now, look at this theta. If this is A and this is A by 2, I hope you can see that theta is 30 degrees. Or you can go for sine theta equals to A by 2 upon A, and you will get theta as what? 30 degrees. That means once this theta is 30, shadow, its length will be A by 2. So, if this length is A by 2, then look at this part. Time at this position is 0. Time at this position is T by 4. Now, let's divide this whole thing in 3 parts. Remember, all these angles are 30. 30 plus 30, 60 plus 30, 90. 30 plus 30 plus 30. And if I ask you time for first 30, time for second 30, and time for third 30, what is the relation between these times? Look, time for first 30, time for second 30, and time for third 30. What is the relation between them? And you will say that since angular velocity is constant for all these 30, 30, 30 partitions, time will be what? Same. I hope you're getting my point. Time for this, and time for this. That will be what? Same. So if you say that time for this portion is t, which we need to find, then time for this portion is also t. Time from here to here, that is also what? T. T, T, T. What is the total time? 3t. What is the total time? 3t. What is 3t? Time to reach this position starting from this position. But you already know that time. That time is what? T by 4. T by 4. This gives you T as T by 12. Look at the advantage. In circular motion model, you know that omega is constant. And therefore, for same angles 30, for same angles 30, for same angles 30, remember all these angles are what? 30, 30, 30. This is also 30. All these same angles, time will be same. But for A by 2 and A by 2, time is not same because speed is not constant. And therefore, instead of using this version, we will use this part. From here to here, t plus t plus t, 3t, and we know that this is t by 4. That gives us t as what? Capital T divided by 12. I hope you understand the advantage of circular motion model. Note down this. Now let's see how we can develop velocity part with the help of circular motion. Let's discuss case 1. You can develop it for general situation also. But let's see this whole thing for case 1. In case 1, this is the rod, and you know that this is the shadow. Just remember that light is coming from this side. You have a screen over here, and this is the shadow at t equals to 0. That's the setup. T equals to 0. What is the length of the rod? A. What is the angular velocity? Omega. If I ask you what is the velocity of this tip, and you know this, what is velocity in circular motion? R omega. And what is R? This length, which is what? A. And therefore, tip of the rod is moving with A omega. But this same tip corresponds to what? Tip of shadow, which means this shadow is also going up with same velocity of v, and this v is coming A omega. You know that when object is at mean position, it moves with maximum velocity given by A omega. Look again, this is a rod, its tip is going up with A omega. If it goes up with A omega, the shadow it casts on the screen, its tip will also go up with same velocity of A omega. Now, this is just at t equals to 0. Suppose at time t we found that rod is over here. This angle is what? Theta. Tip of the rod is moving in this direction. This is V. What is V? Again A omega. In circular motion, you know that velocity always is what? A omega, which is R omega. Now, this is the velocity. Your shadow, it's over here. This is the position of shadow. Light rays are blocked. This is the position of shadow. And we are interested in this V. Which V? Velocity during simple harmonic motion. What is this V? This V is for circular motion. For circular motion, V is what? A omega or R omega. But tip of the shadow is going up and its velocity is what? Velocity during simple harmonic motion. Now, how do you find this thing? Look over here. If this angle is theta, you know that this angle is also theta. If this is theta, then this angle is 90 minus theta. Radius and tangent, which means this angle is what? Theta. If this angle is theta, then what is this velocity? A omega. If this is A omega, then what is this component of A omega? You will say that this component is A omega cos of theta. This is A omega, and component of A omega in this direction is what? A omega cos theta. That means tip of rod is moving tangentially with A omega, but tip of rod is going up with what? A omega cos theta velocity. Remember this part. Listen again. Tip of rod is moving tangentially with A omega, but this tip is rising up with what velocity? A omega cos theta. If this thing is going up with A omega cos theta, then tip of shadow will also go up with same velocity, and therefore this is also A omega cos theta. For simple harmonic motion, when object starts from mean position, you know that x is what? A sine omega t. And then how did we arrive at v? We used to get v with the help of differentiation, dx by dt. Or you differentiate a sine, its differentiation is cos omega t multiplied by omega. This circular motion model is also teaching you how to develop differentiation of sine. Look, we have got the differentiation of sine. This length is x. And what is x? You know, A sine omega t. This theta is omega multiplied by t. Remember that this rod is over here at time t. This is time t. This is t0. So what is theta? You already know. Theta is what? Omega t. And therefore, x upon this length, which is a, gives you sine omega t. So this x, its rate of change is what? A omega cos theta. What is rate of change? This height is x and rod is rising up with what velocity? A omega cos theta. That means x is changing with what rate? A omega cos theta. That change of x with respect to time is called what? Dx by dt. This dx by dt is what? A omega cos omega t. Look here. Dx by dt is coming what? A omega cos theta. What is theta? What is theta? Theta is what? Omega t. With the help of circular motion, we have developed velocity during simple harmonic motion. Now look again. When this rod completes 1/4 circle, when this is the position of rod, you know that tip of shadow will be at the amplitude. And what is velocity during simple harmonic motion at amplitude? 0. Now, what is velocity of the rod? What is velocity of the rod after 1/4 circular motion? That is not 0. This rod is still moving. This rod is still moving tangentially with A omega. This rod is, when at the 1/4 mark, is moving in this direction with A omega because of the angular velocity omega. Now, corresponding position for the simple harmonic motion here, if I ask you what is velocity, then you will go and find component of A omega in this direction. What is this angle? 90. So what is this component? You will say A omega cos 90. What is that? 0. And therefore, when x is A, object is at the amplitude, you know that we say its velocity is what? 0. So we have developed circular motion, velocity of simple harmonic motion with the help of circular motion. You can also see the other result of V. That other result of V was omega times root over a square minus x square, and we obtained this result with the help of integration. Now look here. What is velocity during simple harmonic motion? A omega cos theta. What is velocity during simple harmonic motion? It's coming A omega cos of theta. This is V, remember, for simple harmonic motion, which is A omega cos theta, Now what is cos theta? What is cos theta? You know what cos theta is? 1 minus sine square theta. 1 minus sine square theta. And what is sine theta? Do you know what is the value of sine theta? What is the value of sine theta? Sine theta is x divided by a. This length is a. This length is a. Perpendicular upon hypotenuse. What is sine theta? X divided by a square. A square minus x square, take the root, a and a cancel, and you got your omega as omega times root over a square minus x square. In first and second lecture, we obtained the same result with the help of what? Integration. We wrote a as minus of omega square x, and then a was written dv by dt, and we multiplied v on both sides, and then we integrated the whole thing. Then we use constant of integration and all. All those things can be simply eliminated with the help of V being A omega cos theta. And what is cos theta? Root over 1 minus sine square theta. Hopefully you understand this circular motion interpretation to explain simple harmonic motion. Hold on everything.